Hi, my name is Keith Parsons, and I just wanted to talk a little bit about a single slide. I just have one slide to talk through, and it's what are the steps that happen for a single frame to be transmitted across the RF medium? And we think of things like, well, I'm going to use a 40 megahertz channel or an 80 megahertz channel, or I'm using which MCS, and all of those matter, and yet each of those that matters only changes one thing. In the picture you can see on the screen, it only changes the blue. All the other pieces are part of the protocol, part of the overhead, and there is a ton of overhead. And this would be really boring if I went through every one, but I'll go through every one really fast. There is a arbitration time in determining how long am I going to wait before I transmit. And that's a random number that gets talked to, and Troy just talked to it a while ago in his presentation. And that's the contention window. And then if you win that contention window, then you still have to wait for a preamble, and then an RTS, then a CTS. And next to each of those, I put the time that it takes and the type of modulation. Sometimes it's a fixed time, like a CIFS or an RTS. They all have the exact same fixed time. The data rate changes depending on the piece that's actually going out. Some of them go out basic rate, some of them go out other rates. And as you walk through, to get anything in here, and just on this slide here, the only thing we really care about is the payload. That's it. Everything else is overhead. That's part of what makes Wi-Fi Wi-Fi. This was triggered because Troy's talking about this whole contention process and the randomness of it. Yeah, it's pretty random all in the top part. But once you win that random slot and you say, it's my turn to talk, you still have to follow all of these extremely tedious steps. But that's what makes Wi-Fi do its job. Now, the second reason I wanted to talk about this is we get all excited about things like we're going to go twice as fast because we made a 20 megahertz channel into a 40 megahertz channel or into a 160 or even 320s now in Wi-Fi 7. But if you look at it, it doesn't change the actual total length of time all that much. The only thing that changes when you go to a 40 megahertz channel from a 20 is the blue part is half as large. All the rest of the overhead stays exactly the same. So this was just a quick little review of what a single frame takes to get on the air. And I wanted you to emphasize that you could look at this as well. Troy just mentioned Garamond's calculator. You can do this exact same kind of graphic, go into his calculator, pick whether or not RTS, CTS is turned on, pick whatever you want to set for your basic rate and your data rate that you want to show, channel width, and you can get the same graphics as well and play with it. And I hope what you find in that is, yes, it does change the blue part, the payload changes dramatically depending on what you do. But the length of time for an individual frame stays approximately the same. Thank you.